Okay, the first one we need to do is number 2. So it says, why do we restrict the domain for the function x squared to find an inverse? And it's because we need f of x to be 1 to 1. You would probably write that as 1 to 1 to have an inverse. By restricting domain, we turn x squared into a new 1 to 1 function. So we take this function, which is x squared, and we just restrict it to over here. And if this is its domain, then now it's 1 to 1. That was number 1. Number 5 asked, how do you find the inverse algebraically? You switch x and y, comma, then solve. So you can just go outside. Just let me know. 8. So for 8, we are finding the inverse. If y is equal to x plus 5, we're going to switch, which is this, and then solve, which gets us x minus 5 is equal to y. That's number 8. Number 12 would be, this one is going to take a little bit more room. I'm going to come over here and say number 12. If you have y is equal to 2x plus 3 over 5x plus 4, first thing I'm going to do is switch the roles of x and y. Get this. I'm going to solve for y. So the way that you solve for y is to multiply. The reason we did that is so that these cancel. You get 2y plus 3 and 5y plus 4 times an x. Well, notice this x distributes through. It gives us 5xy plus 4x is equal to 2y plus 3. So now we get y alone. Or, actually, probably a math way to say it would be that you isolate y by itself. So, over here we would have 5xy minus 2y, because we move this that way. And then we take 4x and move it this way, and I would have 3 minus 4x. Well, then notice there's a y living in both of these terms. If I factor it out, I'm left with 5x minus 2. And why is that great? Because now I can just divide. And I get this divided by this is our inverse. So f inverse is just equal to 3 minus 4x over 5x minus 2. So that's 12. Now I go on to 14, and it wants me to find the domain of each function. Find a domain where it is 1 to 1 and non-decreasing. So that means it wants it to be either stable or going up. So if I have 14, I know that this is just this function, but we shift right 6 units. So it's going to be over here at 6, and it's going to open up like this. So if I want to make it 1 to 1, I'm going to have to cut it in half right here. And that would be my 1 to 1 piece. And so we're going to go from 6 to infinity. And then find the inverse on this restricted domain. So now I'm going to come over here. And so if I need to find f inverse, my original function is this. I'm going to switch, which gets me this, and I'm going to solve, which gets me the square root of x is equal to this. Don't forget plus or minus. And then you add 6. So I'm going to get 6 plus or minus the square root of x is equal to y. But I think it should be pretty clear that if we go with the line y equals x, it's going to be the positive version is going to be the one that's going to be a mirror image across the line. Y equals x is going to be that one right there. Okay. So it's just going to be that positive version. So let me go ahead and leave that there. That's fine. All right. So if that's 14, then I need 15. So 15 is, it's y is equal to x squared minus 5. And so first thing I'm going to do is I know that that is just x squared that got shifted down. So if I want to restrict my domain, my new domain restricted is going to be from 0 to infinity, including 0. So it's going to be this guy that goes like this. And then if I'm going to find f inverse, I'm going to take the original, I'm going to switch, and then I'm going to solve. So I'm going to get x plus 5, and then I'm going to take the square root. But remember, when you take a square root, you get plus or minus. I think it's pretty clear here that it's going to be this, oh poop, this is 0, negative 5, this is negative 5, 0. I think our inverse function is going to look like that. It's definitely going to be the positive version. So it's definitely going to be the positive version. Positive square root of x plus 5. Right? Because it's a mirror image across the line y equals x. So that's 15. Where is 16? So 16 has 2 parts. Whoa. So if f of x is equal to x over 2 plus x, and g of x is equal to 2x over 1 minus x, it wants us to find this, and then it wants us to find this, and then tell us what that says. Well, it's going to tell us that they're inverses if they both end up equaling x. So let's see. First, if I take f and plug in g, so I'm just going to plug in 2x over 1 minus x. What f does to things is it ends up putting them here and here. So take stuff over 2 plus stuff, but what you gave it was this and this. So I'm hoping that that turns out to be equal to x, and let me show you why it is. We just need to be careful with our algebra. So I want to get rid of the 1 minus x, so I'm going to multiply it on top and bottom by 1 minus x. If I do that, it hits this and gives me 2x. On the bottom, it hits this and gives me 1 minus x. And it hits this and gives me 2x. So if I simplify that, I'm going to get, by distributing, 2 minus 2x plus 2x on the bottom. That's just equal to 2x over 2, which is x. So that one turns out to give me exactly what I had hoped. Is equal to, right? Let's now do the next one. Move this over just a little bit. So for this one, I want to find g of f of x. So I'm going to take this f and plug it into g. And so what it's going to give you is, if you plug in f is x over 2 plus x. Plug that into g. What g does to things is it gives you 2 times what you give it and 1 minus what you give it. This time we gave it x over 2 plus x. That's what we plugged in. This is x over 2 plus x. So now if I multiply the top and bottom by a well-chosen 1, it hits this on the bottom and gives me this. Hits this and gives me minus x. And on top it hits this and they cancel out, and I just get 2x on the top. Notice on the bottom, I end up getting 2, so the whole thing turns out to be x. So since they undid each other nicely, so f and g are inverses. Yay. That's 16. 23. So for 23, it says determine whether the graph is a one-to-one function. Well, for 23, it is not one-to-one because if you see that the graph looks something like this, it fails the horizontal line test. So it fails the horizontal line test. So not one-to-one. Because if I draw a horizontal line, I can find one that hits the graph at more than 2 points. That means that this x1 and x2 are different, but have the same output. It would mean it's not one-to-one. So it's 23. I need 25. So 25 is f of 0. That means when you plug in 0, what do you get? I think it's clear that the answer is 3. And then for 26, it wants to now say solve f of x is equal to 0. I think that's pretty clear that when y is equal to 0, you get out 2. So x is equal to 2. So this means 0, 3 is on the graph, and 2, 0 is on the graph. So that's 26. And then 27. So 27 is f inverse of 27. 27 is f inverse of 0. So if you undo 0, what do you get back? In this case, I think it's pretty clear that you get back 2. So that means if 2, 0 is on f, then 0, 2 is on f inverse, because we switch the roles of x and y. And then for the last one, number 28, it says solve f inverse of x is equal to 0. So that means what comma 0 is a point on the graph? Well, if 0, 3 is on f, it means that 3, 0 is on f inverse. So that means x is equal to 3. So again, if this is how it works for f, then f inverse takes 3 and sends it over to 0. If f of 2 is 0, then f inverse of 0 gets me back to 2. And here this would be this. So x is equal to 3. Here's x is equal to 0. Here it's x is equal to 0. No, here it's y is equal to 0. This one was x is equal to 2. Cool. Awesome. So have a great rest of your day. Stop.